All right, in this lesson, we're pretty much just going to learn how to identify and draw some rotations, both without the coordinate plane and in the coordinate plane. All right, so pretty much a rotation is just a transformation that turns a figure about a fixed point. There's a much longer definition of a rotation here, but essentially you start with your fixed point. We're going to call that P, and we're starting with our point A. If you imagine that point A is tethered like with a string, and it's attached to point P, and you rotate it, in this case, we're rotating it in this direction, however many degrees you want. That's your angle of rotation, so you rotate it that way, and then you end up at A prime, then that's an example of rotating one point. Now, if you want to rotate an entire figure, as we have here with the blue guy and the black guy there, you would have to rotate every single point in the same direction, the same amount of degrees, and you will have your rotations. So in this particular one, this guy is the pre-image, and then when you do your full rotation, 135 degrees, then this would be what we call our image. Or you could do it the other way. Now, as I'm looking at this, I'm noticing that the arrows go both ways. Or you would start here with your pre-image and then rotate there to your image. Either way you think about it, that's how you create a rotation. Okay, so let's tell whether or not each of these transformations appear to be a rotation. If they're not a rotation, I want you to tell me what you think it is. So for 1A, we've got the blue to the red or the red to the blue. They don't really tell us which one is the pre-image and which one is the image. But it really doesn't matter because it's not a rotation. No? And it appears that this is just a slide or a translation. Okay. If we look at the blue and the red on the other here, it looks like you can take the red and rotate it around a certain angle, and then you would have the blue. So this one would definitely be a rotation. Okay, when you want to do rotations in the XY coordinate plane, we're just going to do rotations for 90 degrees and for 180 degrees. So to do a 90-degree rotation, all of your points XY become negative YX. If you take any point and you switch the coordinates in that way, you will have a 90-degree rotation. Here, if you want to rotate it 180 degrees, all of your points XY become negative X, negative Y. Simple as that. Plot your new points. You got your 180-degree rotation. So we're going to take this triangle here, triangle JKL, and we are going to rotate it 180 degrees. So we've got the point K, which is 4, negative 5, and then we're going to rotate that to K prime, which would end up being negative 4, positive 5. We got the point L, which is negative 1, 6. We're going to end up rotating that to L prime, which is going to be 1, negative 6. And then we've got our point, oops, I'm missing J. J was 2, 2. We're going to end up rotating that to J prime and getting negative 2, negative 2. So I'm going to plot both of them, the original and the pre-image and the image. I'm going to plot the original one in red. So it would be 2, 2. That's J. 4, negative 5. That is K. And negative 1, 6. And that is L. Oh gosh, why did I plot 2, 0 instead of 2, 2? That would be J. So we get this really skinny little triangle here. So now let's plot the other one in a different color. I'm going to plot this one in blue. So we got negative 4, 5. So that's there. That's K prime. And we have got 1, negative 6. So 1, negative 6. That's there. That's L prime. And we got negative 2, negative 2. So that's there, and that is J prime. And there you have it. Now, how do you know it's not a reflection and that it is definitely a rotation? Because if you look at the orientation is the same for a rotation. When I say orientation, I mean if you go in order for the letters, JKL, JKL, I am rotating around clockwise. If I do J prime, K prime, L prime, J prime, K prime, L prime, I'm still going clockwise. So because they're both going in the same orientation, while it looks like a reflection, it is indeed a 180-degree rotation. Okay, for this particular problem, we've got a Ferris wheel, and it has a diameter of 100, and it takes 60 seconds to make a complete rotation. So it looks like this thing does about 6 degrees per second. Shalia just said hi to me. All right, so if it's going to be traveling for 5 seconds, and the steering wheel starts here at 100, 0, and it rotates around to some new point, let's put that point there, and it goes 6 degrees per second, we've made an angle of 30 degrees. So this is our new point XY. We want to find out what X and Y are. This is Y, and this is X, and this is still 100. The Ferris wheel's radius didn't change. We can find X and Y using some trig. I'm going to use the 30, 60, 90 triangle. That means across from the 30-degree side, would be half of the hypotenuse, so Y is going to end up being 50 feet, and across from the 60-degree would be the shorter leg times the square root of 3, so 50 square root of 3 feet. Now you can end up getting a decimal for that, but that's pretty much how you could do it. If you didn't know, you could say the tangent, or not tangent, my bad, you could say the cosine of 30 degrees was equal to x over 100 and solve for x. And then the sine of 30 degrees is equal to y over 100 and solve for y. And then you would get the same answer that I got there. Okay, let's go to the next slide. All right, rewatch any parts if you need to make sure you understand. If you're watching on YouTube, type a question. If you're watching on Weebly, go over to YouTube and type a question. Or better yet, anybody that's watching the video, if you go to YouTube, create an account, and just type your first name and your last initial in the comment section. I'll give you 2 points extra credit. See you tomorrow.